Hello students, in this video what we're going to do is we're going to go over match moving tracking phases, kind of the different stages that a match move goes through before it actually gets distributed to the rest of the departments that need it on the 3D pipeline and the 2D pipeline. The goal of all this is for you guys to get an initial kind of workflow of how you're going to approach a shot. In this case, we're going to take a look at the anatomy of a track before we actually dive into synthesize. So this will give you a better idea. At the end, the goal of the course will be, can you really do this without tutorials? Can you really take a look at a shot, analyze the plate, and go through the different phases on your own? So that's why I'm doing this. So let's go ahead and take a look at it. And I'm going to be creating annotations as we go. So the first thing is to take the plate that comes to your department from the visual effects editors and things like that. We call that process called turnover. And throughout that process, the footage in the plate, in this case, the film plate, get transcoded for different departments. So in this case of synthesize, sometimes they transcode it to us in the JPEG format, but it could also be very well an EXR format or a DPX format as well. So it all depends on what the needs of the production are for that specific tape as well. The goal is to maintain as much detail on the plate as possible to improve or to maintain the quality of the track as we go through. The next phase will be analyzing the plate. This will be extremely important because it's on this phase that you will look at the problematic areas of the shot. You will start designing the plan of action. And I put the notes at the bottom here so you're able to kind of go back to this video and actually see exactly what I'm talking about. Is in this stage that we will analyze the type of camera movement that we're going to have on the scene. So if we understand camera movement, we could see if there's a dolly, a truck, a whip pan, if we're using a type of zoom lens and stuff like that. It's in this stage that we try to collect as much of the data, of the unset data as possible. So like lens grid, camera reports with the script supervisor, we tend to see what lens was used in what shot. And all the camera data if available. The majority of the times in real productions, sometimes all this data, even though it gets collected on set, it tends to get lost in translation. So somewhere along the lines it get lost and we don't have it. So we have to learn how to read maybe the metadata that gets sent to us from the VFX editor or any other data that we could get our hands on. So at this stage, we think of the tracking points. We evaluate the tracking points. Sometimes we go ahead and we press this auto button to see we could actually what the auto will track and see what points it considers as good. Also, we do an initial analysis to see if the plate is good or not. And also, try to identify the most common problems, anything that could cause a problem. So we know that she will cause a problem. If we try to track anything on her, she might be moving. So that might be a no-no. We might not be tracking anything. So this is the most important stage of them all. From here, then we're going to move to the next stage. And the next stage will be thinking about lens distortion is also part of analyzing the plate, but mostly in this stage, we're thinking about the workflow. Do we want to apply the lens distortion first and work in undistorted plates? Do we want to calculate this lens distortion throughout the tracking process, which is the most modern and the most optimal way of doing it? Or do we want to do the calculation of the lens distortion after the fact, after we have solved and recalculated, then send it over? So there's different school of thoughts. The old traditional way that we used to do it was to actually calculate the lens distortion uh, um, before, and then we will undistort the plate, then deliver undistorted plates to the match moving department and stuff like that. And then from there, or the information of the undistortion to the match moving department. From there, they will go ahead and apply all that data into the system. Now, the best way, the best method is in the modern era is the match moving softwares are really good at figuring out the calculations. So if by some reason we have a lens grid that gets provided to us, it will be looking something like a checkboard like this. What we could do is we could pre-calculate the lens distortion using the softwares, the native software like Synthesize or Nuke, using the lens distortion nodes in there. In order to kind of pre-calibrate the scene and kind of get the information of the lens distortion early on to kind of see what we're going to have. But we won't apply that into the system. What we're going to do is maybe use that lens distortion information and use that as extra data that we could feed into the software like Synthesize. The goal will be to in order to get a higher accuracy, it will be to actually apply the lens distortion throughout in the sense of the process, when we actually are processing the whole plate at the same time we're doing the solve and the same time we're doing the tracking. This will give you more accuracy in the process. Now, the reason being is that when you apply lens distortion and you undistort the plate, if you're doing this ahead of time, let's say you apply the undistortion here, you got to realize that if you have a 1080p plate, for example, and you went ahead and you decided to apply the lens distortion before tracking and you deliver that plate we need something called overscan. Okay, because when you apply additional undistorting setup here, you will get this little gray box right here. This is actually the overscan. You will get additional pixels added to the edge of your image. And the reason for this is because when you undistort a lens, depends on the type of lens, if it's barrel or distortion or pincushion, it will either extend towards the outside past the edges of the image. And what you want to make sure is that you are always working with the information outside of that area. So that's why, let's say in this example, let's say we added 10 additional pixels to the edge in order to be able to accommodate the image that went out of the frame of view. So in here we still have the 1080p inside, okay? But on the edges we have to add another additional extra because to compensate for that lens distortion. That's what we call the overscan. Now, in this stage, let's say we did that, then what we will be doing, it will be delivering to the matchmoving department a resolution of 1090, which is not good because if by some reason your lens calculation was not accurate enough, you will introduce additional errors into the calculation of the solve inside of the matchmoving department. So for that reason, sometimes it's better to actually let the software in modern era, the softwares are doing really good on the lens distortion algorithms. We're going to allow the software by turning this little checkbox on when we solve, we're going to allow the software to actually calculate the lens distortion as we are creating trackers and refining for the solve and stuff like that. So throughout the match moving process, that lens distortion calculator keeps getting refined over and over and over again. And what that happens there is that when we get our final solve out of the match moving and we're ready to export, we will have an accurate lens distortion or undistortion that will work with the camera that we're currently working on, with the scene that we're currently working on, and if we didn't introduce additional errors into the shot. So usually at this stage, when we export this final, then we export an undistorted plate, and that undistorted plate goes then into the 3D pipeline, the CG pipeline. So when we are in a software like Maya, for example, that software now takes an image that is not 1080p like the majority of the people do nowadays. If you don't understand what is happening, that it will have a 1090 plate because we have 10 additional pixels. Okay. And when you're working inside of Maya, you're going to be working in a resolution that is bigger than your original. Depends again on the lens. So in this case, the goal is that as you're working throughout the 3D pipeline, you always are going to have these extra pixels. Because what happens is that in Maya, the lens itself doesn't have an optical, it doesn't have glass. It's actually flat. There's no distortion because of glass. So the rays of light are not getting bent or anything like that. In Maya, everything is just straight, right? In that sense. So I'm oversimplifying it. So when we're thinking about that, the next thing is, okay, we have this overscan, right? And we have elements that are getting rendered outside. And the reason for that is that when we take CG renders and we're going to comp it over the live action footage, remember that the original live action footage is 1080p, right? Or HD 1080, okay? The goal is that we never pass the original footage through this pipeline and use the undistorted plate to actually comp. We use always the original plate to comp it against the CG that comes in. So throughout that process, the lens distortion calculation that we generated out of this setup, we actually are able to use it to redistort now, and this is called a redistortion. Using a software like Nuke, we will redistort it now in order to comp it against the original distorted plate. Okay, And that's actually how we take CG and integrate it into live action with the correct lens distortion. All right. So from Synthesize, we could output, thanks to us being able to do the correct calculation in the actual process of match moving, or generating the scene track and solving inside of the match moves, we get a more accurate solve. So therefore, we could generate something called an ST map. And ST maps are images that we use in order to be able to do the redistortion approach inside of software like Nuke. Um, and these are a way of we're mapping the lens distortion into a 2D image that we save later down the road. And you're going to see that process as we go through. So it's going to be very important to understand. It's a little tricky at the beginning, but as we do it, you guys are going to gain more experience through it. All right, so let's go ahead and move along. And let's pull through. So the next stage will be to track your scene and do the initial camera calibration, the initial solve. And if you notice, I already have here something called save version, because this is the first time we start now tracking the scene. So when we open the footage, we interpret the footage and we add all the information in that little brief window of what is the footage, what is the camera sensor size, what is the frames per second. So we put as much information as possible before we start the tracking process. So when we start the tracking process, we have to decide if we're going to be using a manual supervise, an auto. So manual is actually called supervised track, an auto track, or a semi-automatic track. And the best it will be to actually, my recommendation always is to mostly kind of start first with auto to evaluate, but then decide, okay, the autos does a good job, but I need to solve this for more accuracy. That means lowering errors and things like that. So I tend to go with a semi-auto or manual setup. Manual will give you kind of the most accurate because you're actually placing the trackers exactly where you need them. So you're deciding where to place them. But never underestimate the semi-automatic process, because the semi-automatic process could get you there a little bit quicker, and then you could use supervised tracks in order to fix the automation, and put trackers exactly where you need them. But by placing trackers where you need them doing the supervised track, you will be able to establish like scale and distance constraints that are necessary for us to be able to do it. You also could place in areas to establish coordinate systems and things like that. Now, it's throughout this point when you do the initial solve that you want to turn on that calculate distortion that we talk about. And this is kind of an idea of a number that it will give you. Over here on the top, we don't see it, but it also gives you a lens associated with that. So, like I said before, you will notice that on the top here, anytime that you want to save a version before you go to the next step, you will see this guy on the top. So when you do your initial 2D track, make sure that you save a version before you actually do the initial solve. And then solve and save a new version with the solve in place. All right, so moving on. Let's go ahead and what you're doing there is guaranteeing that your process is clean from start to finish. Right, so now that we have done the initial solve, it's time to set up the coordinate system. So in this stage, what you're going to do, or in this phase, what you're going to do is to make sure that you establish what the origin is. And the origin, we actually set it up to 0, 0, 0. And that establishes the center of the world. Okay, now the next thing is establishing the x-axis or the z-axis, or what is a floor and what is not. So the important thing here to understand is, in order for you to be able to establish an origin, okay, an x-axis or a z-axis or a y-axis, you need to be able to have a high level of accuracy in those trackers, and they need to be exactly on the axes that you're trying to constrain. So essentially, let's go ahead and erase these. So essentially, if I set up an initial tracking system, right, where I have, where I actually have this setup right here, okay. Yes, we established the origin. We said already that 0, 0, 0, okay. But then we could establish one of the axes, that is this one right here, okay, that to say that is our z-axis, and we decide that is going to be the front of our scene, and that's perfectly fine. But what you got to remember is that that axis now, if let's say we are 1 unit, 2 units, 3 units, 4 units, right? So let's make believe that that is perfect 4. So 0, 0, because this is x, y, and then in the axis for the z-axis will be, let's say, 4. So that's now established as that's the new axis for the z direction, and that's pretty much this guy right here is 4 units away from that origin. But that now comes the problem. A lot of people will go ahead and set up the x-axis now, and they will say, okay, now this will be my x-axis, and they pick a point. And in here, you notice that point right there, that point is not on the ground, right? But yet you decided to pick that point as the x-axis. So let's say it's set that at x. So in this case, that point, you'll notice that it's a little bit higher up. That point is actually on x will be, let's say 0, because that's what you want, or let's say this 1, 2, 3. Let's say 3. Let's actually go with what we see on the units there. Let's say that point is on 3, but then that point is slightly up. So let's say on y, this is x, on y, that point will be, let's say 0.25 up, and then all of a sudden 0. But when you're constraining that point, you're saying that if that is on the x-axis, this value of y needs to be also 0. So you're forcing the whole scene to conform to that. So it's saying, okay, this axis right here, I want you to move it down. So what happens there is, because you don't have an accurate setup, there is a problem there. So let's take a look at the top view there, and let's set it up with the top view. Let's say that x-axis, that point, let's move it off, and it's around there. This is the origin, and let's say we have the point here for the z-axis. Let's change the color very quick. And let's say we set up that point to be the x-axis, and all of a sudden when we hit solve again, by doing that constraint, we're forcing that point to be here. Okay? And we know definitely that point is not there. So that will introduce a problem, and it will give you an inaccurate solve. So the constraint system is super important to understand what it is. So it's preferred to have like origin and axis, no matter which one you want to use to establish front or side. And then from that point, find a point in the world and set that to what we call a floor. And what that will do is, no matter which point I select here, one of these, I just set those to floor, and it will not destroy my setup. And the reason for that is because when you're establishing an axis that is perpendicular to one another, you're looking for a 90-degree angle. But if the point is not 90 degrees, we have a problem, right? So if the point is here and you're moving it over here, that was not 90 degrees. So when you're forcing that 90 degrees on something that wasn't, your calculations will be completely off. So when you do a coordinate system, before you resolve, also go ahead and save a version of this, even if you get a nice setup. The majority of times, if anything happens, we could establish and align the scene also manually using the lens panel align features, and we will go into that as well. All right, so moving on. The next thing is, let's go into the final solve of the camera and refine for errors. So after you have established the coordinate system, you figure out the way that you were going to do it, you decided to only do one axis and some other trackers as a floor, then you go to refining for errors. What you're doing there is you have a good solution, but you're making sure that the horizon is not that high. So this horizon, for example, the whole camera here seems correct, but the horizon is really, really high. So you're looking for what is causing those issues. What is causing those problems? Could I fix that? How do I fix it? Do I need more trackers and things like that? In Cintize, there's a blue line which tells you where the horizon will be and things like that. So if there's something wrong, you're going to notice, wait, that is the horizon. It goes all the way up there. When we actually see it's the horizon is way below here. So there's problems there. So that means I probably need a couple more trackers in order to be able to find a more correct solution, or I need to remove trackers that are introducing a lot of problems or a lot of issues, or refine those trackers. For example, there's trackers on the body of the person in this one. So if she's moving, that might be introducing an issue, and the camera might be bumping up or bumping down. So you want to fix them as necessary, and anytime that you fix trackers, or you have to go ahead and run the refine solve. And in this stage, you want to make sure that you also have a save version before you actually do this refinement to make sure that you could always go back to it. All right, so moving on. From this scenario, the next thing that we will do it's going to the final stages. In this case is the scene reconstruction, and from there, what we're going to do is we're going to make sure that to recreate the geometry, and using manual trackers, supervised trackers, allow us to be able to easily identify the locations. Also, you notice the colors on the trackers. What we do this for is to be able to group the trackers in unique colors, so that way we can select them easier. Also, throughout this stage, we could add zero-weighted trackers. They don't require for the scene to be resolved in order to be able to find a location. They will use the current calibration of the camera, the current solve, in order to be able to find their way into the location that you need them. They're not going to be 100% exact because we are always averaging here, but it could give you an idea. You will use very basic building blocks in order to achieve this. You don't need to use anything complex. Cards, cubes, cylinders, and stuff like that. Also, you'll notice you need to save a version of that. And the last but not least, with one more stage to go for the exports, will be the render and exports. And I call it the last stage of essentially exporting the synthesized scene, but we have one more stage before after this. So render and export, what we want to do here is we want to start outputting previews of this. And you might do this when you do also your initial tracks, when you're doing reviews. So you might render a preview, and in the preview, you want to make sure to set all features to be visible. You want to make sure that you can see the trackers. You want to make sure that you could see the colors of the trackers. You want to make sure that you see the wireframe. If you want to see a little bit of the solids, then the opacity needs to be down. You don't want any of the solids to be blocking 100% your view of whatever is behind them, because you need to be able to see if they're holding. So a semi-transparent kind of view or wireframe view for those objects is the ideal scenario. It's at this stage that we will export these meshes as well and the track itself after the preview in order to send it either to Nuke, including the ST maps, stuff like that, or Maya. And we will start doing some tests. Sometimes we have to go back and forth and do a round trip to kind of test it before we actually send it out of the department. Now, the last stage, when we're really sure that everything is working and we set up our renders and our exports already for the geometry and the scene itself, for the other packages, other DCC packages, you got to make sure that you save during these versions as well. What we're going to do is the last but not least, we're going to go back into thinking about the undistorted plate. So where do we use the undistorted plate, the overscan plate? This is the plate that needs to be sent from Synthesize with the lens distortion or undistortion applied to it. And in this case, on the solver panel, we will find the lens workflow. And in the lens workflow, when we click on that, we get a panel like this. And what we're going to do is we're going to redistort too. And what this does is essentially applies the lens distortion, the undistorted, applies the lens on distortion, and also does the overscan. And what that allows us to do is from there, we could go back to the summary panel and save the sequence as a JPEG compression for Maya, to be able to send it to Maya, to be able to send it to Houdini, any of these digital content creation packages like Blender, in order for us to be able to continue doing the 3D pipeline and then correctly, so they could actually deliver the CGI correctly to us. So that's pretty much it. After you get kind of the hang of it, this has given you a quick overview of the different phases that we go through in generating or analyzing a track. And it usually is always kind of the similar phases all the time, maybe in slightly different order, but you always will think about these things. I hope this helped you out. Have a good one. Take care and see you on the next podcast. Bye bye.